Okay, we're going to continue talking about triangles. This is still Unit 4. This is Lesson 6. We're going to talk about overlapping triangles. Sometimes it's hard to see triangles in the pictures because they overlap. So we're going to practice looking for all the triangles that are in the pictures, not just the obvious ones. And to help us practice with that, let's look at some pictures of other things. Now, a lot of people, when they see this picture, immediately see an old lady looking at an old man. But if you look closer, you'll see there's also a person right here, like in a sombrero, and then another person in a sombrero with a guitar, and looks like a lady looking out a window here. And then not only that, but if you look, you'll see the space between the lady and the man, or the people in the sombreros, as a vase. So there's actually at least 3 different scenes going on in that one picture. And what do you see in this one? I most obviously see the picture of a woman. There's her eyes, and her hair, and her mouth, her nose. But if you look again, you'll see 2 horses. See these horses? And these birds. And more birds that look like eyes when you look at it the other way. Okay, this is one you may have seen before. What I first see is the picture of a woman's profile looking away. Here's her chin, there's her eyelash, and her hair, and then this is like a veil or something she has on. But if you look again, her ear looks like another eye, and this could be the nose of an older lady, and this is her chin. I'm sure you've seen some of these illusions before. And here's one that looks like an elephant. It is an elephant. But where are the legs? Where do the legs begin and end? See a leg here, and one here, and one here. So you have to look carefully. Okay, here's another one. What do you see first? I see again the silhouette, the shadow of a woman's face. Eyes, nose, mouth, her hair, these are the shadows. But maybe you see the guy with the big nose playing a, what is that, a saxophone? I'm not really sure of my instruments. Okay, and there's his feet. And do you see a rabbit or a duck? So sometimes there's a lot of things going on in a picture that we don't realize, such as this triangle. How many different triangles do you see? Pause for a second and count how many you see. Okay, well, there's one there. There's one here. That's 2. And another one here. That's 3. Another one there. That's 4. And then 2 right here. It's 5 and 6. Can you see all those triangles? Okay. So again, oops, I'm not sure I have enough colors, but here's one big one in green. It's probably the most obvious. Then we've got this one, and another one that overlaps it right here. Okay? And then we also have this one in the middle, and the 3 on the 2 on either side of it. Okay, when we start doing proofs with triangles, we're going to have to consider all the overlapping triangles in the picture. So for instance, if we are given this picture and this set of statements, we're given some angles that are congruent, and we want to prove that segments are congruent. Again, from our last lesson, You should know that if you want to prove that a part of triangles are congruent, then you're going to need to prove that the triangles are congruent first. And then you can use the corresponding parts of congruent triangles or congruent theorem to prove that those segments are congruent. So first, let's figure out the triangles we're talking about. Well, we're given angle TRE. So TRE is that angle. And we're told that that is congruent to WER. So that's congruent to that angle. Okay? In addition, we're told that RE, with this big angle here, is congruent to TER, with this big angle here. Now, does anybody see some overlapping triangles? Well, I see this triangle TER. You see this green triangle here? Overlapping this red triangle, WRE. Okay? Now, maybe we ought to separate these out in our picture so we can get a better look at them. Okay, so here's TRE. And here is WRE. Okay? Well, we were given at this angle here, WER, is congruent to TRE, which is this angle here. Okay? And we were also given that TER, this angle, is congruent to WRE, which is this angle. All right, we've got two angles now that are congruent. Well, we need a side somewhere. And what do you know? They share a base, RE. And RE is congruent to RE. So now we can prove these triangles are congruent by angle, side, angle. Okay, let's do it. So our first statement is always going to be our given. Angle TRE is congruent to angle WER, and angle WRE is congruent to angle TER, and that is given. Okay, so remember, if we're going to go with angle, side, angle, we need to show our congruent statements of our two angles and our side. Well, there's our two angles were given to us. Now we just need to show this side. So RE, segment RE, is congruent to segment RE. Why? Reflexive. Okay? So there's our segment. So we've got angle, side, angle. We've got the congruent statements in our proof. So now we can say that triangle WRE is congruent to triangle TER. Okay, note the order that I put it in, WRE, okay, because angle R is actually, this angle here, R, is congruent to this angle E, okay? And our angle E here is congruent to our angle R over here, okay? And that's because if you look at the original picture, there are two different angles that could be associated with angle E, and two different angles that could be associated with angle R. But when we separated them, this is how it turns out. That's why I use the green to show the ones that are congruent and the red to show the ones that are congruent. Okay, so and the reason we can say those triangles are congruent is because of angle, side, angle postulate. But we're trying to prove that these are congruent. And now we can actually say they are. And again, if you look at the order in which we wrote our triangle congruent statement, we've got WR is congruent to TE. And the reason we can say it after we prove the triangles are congruent is that corresponding parts of congruent triangles are congruent. And we are done. Okay, let's do one more. Now we're given these statements and this picture. Okay, we're given some more angles. We're given segments congruent. And we're given some measures that equal. Okay, so let's see if we can mark this one up. We are given that angle EBA is congruent to angle ECD. So those two in blue are congruent. We're also given that side segment BE is congruent to CE. Okay? And we're given that AC equals BD, and if AC, the measure of AC equals the measure of BD, we know that they are congruent. We're going to have to state that, but we know that they are congruent. So this is AC, okay, is congruent to BD. Notice there's an overlap there. Okay? We're going to try to prove that angle A is congruent to angle D. So let's look at what we can do with this. Well, we're going to have to get some kind of triangle congruence. And let's see if we can find an overlapping triangle. Well, I see this one. Oops. Okay, you see that red one that has BD as one of its sides? And then there's this blue one, AEC, that has AC as one of its sides. All right, so we're getting somewhere. Let's draw them out. Let's pull them out here so we can look at it better. Okay, this is E, A, C. Okay, you see that, the blue one? And this is E, B, D. Okay, now let's mark what we know here. Well, we know that EB is congruent to EC. Okay, and we know that AC is congruent to BD. All right, but we're given that this angle is congruent to this angle, and that's kind of like right in the middle of our triangles. But what if we could get this angle congruent to this angle, not this one? Then we could use side angle side, right? Side angle side. Well, let's look at this. So that is actually this angle, this green angle, right? Here. And then this angle EBC, EBD, is this angle. So angle ECA is this angle. and this angle. Now, if we can figure out how to make those two congruent, to show that they are congruent, then we'd have side, angle, side. And again, we're trying to prove angles are congruent, but in order to do that, we're going to have to prove that the triangle are congruent first. So let's look at this. Well, what do you notice up here? What do you notice about those angles? We have linear pairs. And we were given this blue angle is congruent to this blue angle. So if this is a linear pair, then these two are supplementary. And if this is a linear pair, then these two are supplementary. And we also learned a couple days ago that if two angles are congruent, then their supplements are congruent. Okay, I think we can work with that. Let's do it. First statement, always you're given. Angle EBA is congruent to angle ECD. And segment BE is congruent to segment CE. And AC equals BD. Okay, we saw that because it's given. Okay, well, we're given, so we're looking for side, angle, side. Okay, we were given one of our sides, congruent statement. Our other one is given as an equality. We're going to have to change that to congruence, but we can do that. We can say that AC, segment AC, is congruent to segment BD because if the measures are equal, then the segments are congruent. If the measure of the segments are equal, then the segments are congruent. Okay? All right. So there's our two sides. Now we just got to get that angle. Okay, we are given that these angles are congruent, and we can tell that these form a linear pair. So we say angle EBA and angle EBC, or D, form a linear pair. In addition, in the same statement, we can say that angle ECD and angle ECB also form a linear pair. Okay? And that's definition of linear pair, or you can refer to the picture. So from there, if you remember our linear pair proofs, the next thing we need to state is that they are supplementary. EBA and angle EBC are supplementary, and angle ECD and angle ECB are also supplementary. Okay, because linear pairs are supplementary. Now we can state that angle ECA is congruent to angle EBD because if two angles are congruent, and we were given that these two are congruent, right? Right there. We were given that in the given. These two are congruent. Then their supplements are congruent. Maybe to be more explicit, I should have said EBD here. And ECA. Just because EB, it could be, you could name it EBC, but it's not in our final picture here. So let's do EBD and angle ECA. Okay, so if two angles are congruent, then their supplements are congruent. Okay, so now we've got our angles. We have our two sides. So we can now say that triangle EAC is congruent to triangle EBD because of the side angle side theorem. Okay, and again, note that we lined up our C and our D. Oh, C and our B. Oops, did I not write this correctly? Let's look again. Yeah. So it's actually, these two should be the other way around. So always check yourself. Even the best can make mistakes. Okay, so EAC, so we need angle C and angle B to line up, and therefore angle A and angle D to line up. So it's EDB. All right? So now C, angle C lines up with angle B, and EC, segment EC lines up with segment EB, and BD lines up with segment AC. So always check your congruent statement. Okay, but are we done? We just proved the triangles are congruent, but that's not what was asked. We were asked to prove these angles are congruent. So we have one more step, and that is to show that the angles are indeed congruent, A and D. And the reason, because corresponding parts of congruent triangles are congruent. And now we're done. Okay, let me pull that over, make sure you can see it all. And that's it.